Video 2, the Intuition Sticker Books and Donor Pools. Welcome back to Second Breakfast AI. I'm Chloe, and in the last video, we talked about why missing data is such a problem. Today, let's build the intuition for how predictive mean matching actually solves it. Let me explain PMM with an analogy. Imagine a sticker collection book with some stickers missing. You want to fill those empty spots, but with stickers that make sense, not random ones. Say there's a gap in the animal section between a cat and a dog. Here's what you do. Look at your complete pages and find similar spots, other places with cats and dogs nearby. Then, instead of drawing a new sticker yourself, you borrow a real one from those similar spots. And you don't just pick the single best match. You find your top 5 similar spots and randomly grab from one of them. Why random? Because if you always picked the same match, 10 similar gaps would all get identical stickers. Real collections have variety. That's PMM in a nutshell. The stickers are data values. The book is your dataset. Empty spots are missing values. Similar pages are similar observations. Now let's translate this to an algorithm. 4 steps. Step 1. Build a prediction model. Take all your complete cases and build a regression model that predicts the missing variable from other variables. If salary is missing, predict it from age, education, job title. Step 2. Generate predictions for everyone, including people who already have the value. This seems weird, but these predictions become profile scores that let you compare people on a single dimension instead of juggling multiple variables. Step 3. Find the donor pool. For each missing case, find the complete cases with the closest predicted values, typically 5. We call this K equals 5. Step 4. Randomly select one donor and take their actual value, not the predicted value, the real one they reported. That's why it's called predictive mean matching. The prediction identifies similar cases. The matching borrows real values. The magic is in step 4. By using actual observed values, you automatically get plausible numbers that preserve the distribution of your data. In the next video, we'll walk through a concrete example with actual numbers so you can see each step in action.